Well, hello there, everybody, and welcome to SkyTour LiveStream from the desert. Uh, I expect you should be able to hear us. Make sure that everything is working for you. Daryl is here with me. Hi, Daryl.
Hello, Mark. Hello, everybody.
It's nice to see you all out there. And Marianne Robb is here. Hello, Marianne. Marianne's actually in the other room getting things ready. She's going to be heading to a fishing tournament. And then I'm going to be heading to Colorado tomorrow. Right near you, Daryl. Actually, how far is Centennial from you in miles?
Oh, Centennial is southeast Denver, I guess. Uh, it's an hour or so away.
Okay. Well, here we are. And as you can see, we have a moon. But this is actually, we're at 150%. If you look up to the top right there, we're at 150%, which shows you that the image quality is so much better. We just have such a drastic improvement over what we had before, so it's really quite nice. Um, so we are in a wonderful location, and there's a first quarter moon out, so it is kind of a little bit bright out there, but we have the special filters which turn the moon blue, so it's not that bad. So, blue moon, that's right. That's right. I have my water, so with water I can do anything.
I have my cup of tea.
Mm-hmm. Yep. He got his T PDQ. Oh, pretty cool. All right, let me just modify this pop filter thing. Okay, there we go. So tomorrow I leave and go to Colorado to speak for the Mutual UFO Network's Colorado group, and then I go back Sunday to Connecticut, um, and Monday I film with Ben Hansen on an episode of the UFO Witness program. Uh, Ben and I did that alien invasion Hudson Valley together, and they're going to have me in to do some analysis for them for this series, so that's kind of cool. Let's see now. All right. Okay, everything looks fine. Everything's on track. Everything's working. Daryl, I think your volume is good, yes?
I hope so. Anybody tell me if I'm too loud or too quiet?
Yeah, there you go. That's what you need to hear.
Look like I'm spiking in the yellow.
Yeah. I do want to say hello to Tara, who's here. I see Isabella is with us. Donald Kunzer, welcome. And this guy, Daryl, is all over the place. I don't know what that is. And Raymond Bobel, how are you, Ray? It's so good to see you. Hope things are going well for you out there. Um, and PG is with us. That's Petita. Hi, Petita. Cypher 2 is here, of course. Um, and we have a number of other folks here that were here. I saw somebody. There's Dalai right there. And we have out there waiting for us. We have C&D Boy is there. Excellent. Good to see you, my Canadian friend. And so I believe that's all. And Isabella, I think I said. But I believe that's everybody so far. And I got you, Tara. Tara's up at the cabin, aren't you? Oh, then we have the big dog. Hey, the big dog is down in Baltimore. That's right, down in Baltimore. Yeah, and Marianne something. Marianne who? Marianne Robb. Yeah, and then we are ready to go. And if you guys have any questions or you want to see some objects that you know of, let me know. You might check out the last post that I did, and you can see some beautiful images that are just outstanding. This telescope is performing miraculously now, and it just took some adjustments to get the alignment straightened out in terms of the alignment of the optics. And once you do that, it's perfect. And from Southern California, we have Volkisch Fräulein. Welcome to the stream. Nice to see you here. And Anahata77, yay. Bonnie's with us. So good to see you. And we're going to keep moving along here. Preston Paget, nice to see you. Thank you for the compliment. The scope's looking good, you're right. Yeah, really happy at how it's turned out. It's just amazing. And there is an image I want to show. But I don't, I'll have to probably, I have to add it in. I want to actually figure out a way to show this image to you because it's kind of cool. But it's an image of the telescope. As you can see, the moon is in here now, and the blue haze, as I said, is due to the filter that we're using. I could add a correction element into the broadcast software, but we're not going to be on the moon for long. You'll see up here, if you look up there, okay, up where the arrow, my arrow is here, you can see the exposure time on the camera control. This is the camera control panel right here. The exposure time is 9 milliseconds, and I have the gain at 0. Now we use a gain of 350. The gain's at 0, and 9 milliseconds is still too much for the edge of the moon, as you can see. It's overexposed there. If we want to get this just right, we'd have to actually drop this to like 6 milliseconds or so. And then when we do that, you'll watch that this exposure will change. Now you see that that's just about right down at the brightest spot right here. Okay, pretty cool, you know. So that said, I think we are in good shape for tonight, and we will be taking on some new objects here. Daryl's brought some objects for us to look at tonight as well. In his efforts, he'd like to see us check out a few things, and I would love to see us check out some more. And we'll do that, you know. So I think that we're doing okay here, to be honest. We have a very good setup here for us tonight, you know. So, Daryl, tell us
Sure.
what you would like to see tonight.
I only remember the one offhand. It was NGC 1333
All right.
uh, in Perseus. Is Perseus up high enough yet, or you need to wait a while?
Let's go check it out. Along with everything else, we have our amazing planetarium system here, and we will bring up our objects. We'll bring up our constellations. Okay, so we have our work cut out for us here. Let's go up and see what's up. And I do see Pegasus and Andromeda galaxies up here, and Perseus and the double cluster actually right here. So there's Perseus. So we actually, let's see how high that is up in the sky. Let's just add some extra lines here that get the elevations. Perseus is just about 30 degrees up in the sky, but I don't know what we're looking at, what you want us to look at. If it's above that, if it's in the northern area, is it in the region of Perseus nearer to Cassiopeia, or the other way?
I don't know offhand.
Okay.
Just try put in NGC 1333 into search.
All right, let's do that and find out. Hey, Skunk Ape, how you doing? Nice to see you.
Might be a little low yet.
Maybe. So 1333.
Yes. You have 13,333 there.
Add an extra 3. Is that 1 second delay?
I think they only go up to 7833 or something like
Yeah,
that.
they do. It's the 1 second delay. I didn't think I hit it, but I did. We can see it. It's right there. Okay.
Well, it's actually not too far from the Pleiades.
No, not at all.
We can try it if you like. I don't know. It might be better after the moon sets.
No, I'm sure it will be
Yeah.
because it's got a reflection nebula in it, I believe,
Uh-huh.
and that reflection nebula is also going to be blue. The moonlight is blue, so it's going to be kind of tough to see that. Focus Fryland says, "Gonna get my astro binoculars out soon." That's excellent. What do you got? What do you got for binoculars? Let us know. Okay, so we're gonna focus on things that we can see right now and that we can do right now easily, and that's probably not gonna work right now. So let's go up a little higher.
I've shown you my binoculars, haven't I, Mark?
The binocular telescope.
Yeah.
Yeah, that was beautiful. You made those.
Uh, well, I bought the tubes and I designed the mount and built it.
Yeah, yeah. That's beautiful. Okay, let's. All right, we're gonna do this. Okay. Um, you know what? I actually want to see the blue snowball, and there's a reason. Because in the past, I couldn't look at things like this because we couldn't support zooming way into things. But now, we can support that. So I'm going to look at it. So here we go. We're going to send the telescope off to the blue snowball. Over my head, you'll see the telescope start to move. There it goes. And it's heading for a star that it will use as a star hopping target in order to get us to the object we wish to see. And that star might be any one of the stars near it up there. So let's first of all get to it. And we'll take a look here. And we're not going to see anything yet. You know why? Except the gain is 0. And what I want to do is set the gain to 350 or so. And instead of 6 milliseconds, we're going to go to 1 second. And all of a sudden, stars will appear. There we go. And we're, of course, zoomed in at 150%. So we're going to zoom out to the auto-sized image. And then we're going to do the hyper shot here to make it look like this. Okay, now that must be the blue snowball. Could I be wrong? Seems like it's sticking around. Oh yeah, that looks blue to me, doesn't it? That look blue to you?
The blue thing I see is a little bit to
This
the
guy?
right of center, right there.
All right. Maybe we are looking at two different things. I think we are. I gotta just lift this up. You might be right. That could be it. I have to check. All right. I want to thank everybody for coming out tonight. And we'll see you later. No, I'm just kidding. That, I think, is the blue snowball, Daryl. And let's stack it. But first, we'll decide. Star hopping is like bar hopping, Skunk Ape says. Well, I guess so, except that the more bars you hop to, the less the stars are focused. Okay, gotta change this to 350. Gain. And this 1 second is gonna go to 3 seconds. And then we will stack. Well, it still could be this guy or that guy. Not sure which. proper colors in here. Alright, we'll do this. Alright. Well, that definitely looks blue now.
Yeah.
So it must be it. Let's add a little. So what is that? Why is that fuzzy? Hey, I know. We can just go check out what it looks like. The blue snowball is actually a planetary nebula, guys. It's a remnant of a star that has died. But what we're going to do is, and in fact, a round ball like that is sensible for a star that's puffed off its outer layers in a fairly regular manner.
So the planetary?
Yeah.
Yep, it sure is.
Yeah, there it is. And we actually have overexposed it. We might be able to see some more detail if we shorten the exposure and start the stack over. Okay, that's just a star right there. And so let's come down to the planetary again. Vera Lucia Campos, is she here?
She is.
Hello, Vera. Welcome from Brazil. And now let's reduce the exposure. We use 3 seconds at 350 gain. I'm going to drop the gain down to about 100. I'm going to kiss down to about 100. 118, say that's good. I'm going to clear the stack, let it replace it, and see what it looks like. Okay, that's looking interesting. Now that we can support this zoom, let's actually do that. Let's zoom in even more. This makes it so much different. Let's go to 125%. All right. Okay, now.
Looks like a green snowball.
Yeah, it does. I think that's a color anomaly. It might be bluish green. Let's try this. Okay, now see we're starting to see some extra detail in there. So again, I'm going to reduce the gain down to 0. I'm going to clear again. And I'm going to keep it at 3 seconds. We might go down to 1 second here. Let's find out. Alright. And now we're stacking, by the way. So we're stacking every 3 seconds here. So it's going to give us a clearer view. Yes, it looks like a glow in a cat's eye. Terra is right. Okay. And that's pretty interesting. But it's still too bright. I'm going to try dropping this down to 1 second here. And then we're going to clear this and start going. Okay, now we can start to see some of the structure in here. You see that? There's some interesting structure in here. And I'm going to add the unsharp mask to see if that helps or hurts. Alright, that actually helps. So you see the structure now? We can see that there's some structure within the blue snowball. And just for the record, to give you an idea how small it really is, we'll go back and zoom out to the full frame here so you can see it. There's that little dot right there. Isn't that incredible? That little dot, the colors aren't quite right, but that's okay. We're doing an analysis, so it's alright if it's not quite right. Let's see if we can get some better color in. That's better color. Now we're going to zoom that. Let's go back to 100%. No, I'm not a floating head, but that's going to change. I'm in Arizona at the moment, so I will be a floating head upon my return to Connecticut when I go back into my studio. All right. All right, so let's back this off a little bit.
La guillotine, la guillotine.
That's right.
It's a blue raspberry.
A blue raspberry. Hmm.
Skunk ape wants a blue snow cone.
Oh, really?
Those are typically
The blue raspberry,
blue
yeah.
blue
That's
raspberry,
right.
Which I've never seen a blue raspberry, but
I never either. Okay. Well, I think that that's pretty interesting. We actually probably need to, go from 1 second, leave it at 1 second, but we can actually increase the gain a little. Say, go up to like 50. Clear, and look at this again. Oh, that's interesting. Got some work to do on it still. Oh yeah, fascinating. I love this. This is cool now.
thing must be pretty bright.
It is pretty bright. It's probably pretty distant, so its relative brightness is condensed into a very small package, so it appears brighter.
I mean, 1 second shot for and gain that low.
Yeah.
I have a list of things to look at if you like.
All right.
We've seen them before, but it may be a whole new deal with new and improved telescope.
Yeah, I know. You're right. Okay, here's what we're gonna do. We're gonna get out of the stacking here, and we're gonna go here. We're at 1,000 or 1,000 milliseconds. We're gonna bring ourselves back to our 350 gain, and then we'll come back. Oh, see, now it looks different. See, very cool. All right, what do you got? What you got, Daryl?
Oh, just a moment. Uh, NDC 7822.
Oh, okay. And that's in
Cepheus.
Cepheus? Yeah, okay. I remember that guy. We should be able to see that. Alright, and that'll be over here. That'll be here. 7822. We're going to do this, and we're going to.
That was the easiest thing I could think of was to go back at objects we have looked at in Cepheus.
That's fine.
A whole list of them. I bet they'll look shiny like a new penny with the collimation set on the telescope now.
Yes. If you guys saw the post from earlier, where I actually showed photographs of the new telescope system in operation, you saw what looks like professional large observatory photographs. We could zoom in 150, 200% and see the most amazing detail. So, welcome to a whole new world. It's a whole new world. Okay. Up there you see the telescope over my head. You see the telescope pointing up toward the north. That wall is toward the north. The wall to the right is toward the east. And the roof rolls off to the east because there's a light dome from Phoenix 65 miles away. And that just gets in the way. Well, I see the nebula. With the moon, it's a little tough, but I think I see it right here. So let's do a simple exposure without stacking. Let's just do a 25-second shot and see what we've got. Alright. Okay, so in the lower right you see the progress bar over there. That progress bar right now says 10, 11, 12, and on the right side it's counting down, and the green bar just gives you a visual aid for how much time is left. Sorry about that, Dalai. Okay, and if we wipe this out, you'll see the nebula once I pull it back in slowly. That's not slow, that's a blast. I think I look in here, right?
I think so.
Yep. Marianne is here. Hi, Marianne.
Hey, Mark.
How are you?
I am good. Hi, Daryl. Hi, everybody.
Hi, Marianne.
He says hi. Yeah. We're cranking away here. Okay, we're going to move this up. The secret is in the stacking. Okay, now keep in mind we're doing, right now this is a 25-second shot. So I'm going to go back to just 1 second. So we know what we're looking at. Alright. And then, 1 second, there we go. Okay. Okay, and now when we do this, we should see there's a nebula here. There's a very faint nebula right here. But don't take my word for it. Take it from a 25-second shot done as a stack. Cipher 2, what's going on, brother? We're going to clear this one. The stack has been reset. Isabella says hi to Marianne as well. Marianne's also listening. Alright, that doesn't look too hot, but I think that's because we have to there we go.
There it is.
Yep. Yep, and you see there's a lot of red here.
Yeah.
It's a bright nebula within lots of other diffuse nebulae. And for a nebula like this, on a night like this where the moon's out, it's first quarter, we really have to bring our black point over. And that basically takes the light gray areas and makes them more black. So we can see more of a contrast, see? So now you see it's more contrasty.
Yeah.
And we'll just put that there, and there you go, look at that. That's beautiful. And the nice thing is, it's a pretty big nebula, but we can actually take us up to say 75% here of full size. So let's take a look at this right here. Okay, there's this guy right here. Now we see modeling because we still have some noise, because we need to stack more than, right now we have just 4 stacked. When we get to about 10, then this multicolored noise in the darkness starts to go away. And it'll be perfect. But you see, this is really cool. It is really very different from what we were used to. All right. Now let's try bringing this up for a moment. It's already getting prettier looking.
I see a Bigfoot print, Tara.
Oh, really? Oh, actually, let's look at that. Is this the foot, Tara?
I see a big toe at any rate.
This?
The big toe up above
This?
to the left. That.
Oh, okay. So this is the
That looks
foot
like a big toe.
with a wart on the whole foot. Wow. This is pretty.
I was hoping Cepheus might be good for now, since I think it's just about straight up at that location.
Yeah, you look at the telescope in the building and it is.
Yeah.
It's fine. I think we just need to, darken it a little like that. In other words, we gotta make this darker overall. See that?
Uh-huh.
Gosh, it's such a rich area. Look at that, guys.
Yeah.
And Skunk Ape Farm Off Grid says, a skunk ape footprint. Tara says that's it. Okay. Yeah, we're going to keep just letting this go a little bit. Notice how this area right here is just a little bit brighter. This is where there's a young cluster here, see?
Yeah.
And that young cluster causes this entire area to glow just a little bit brighter. And that's really kind of cool. And then down below, right, we have these stars embedded in this area, in this gas, and it's causing that gas to glow. This star, I don't know if it's actually in the foreground or actually in the nebula. I'd have to look. But I like this little pillar right here.
Yep. There's a little skinny one just to the left of
That's
it.
right. And if you notice, we talk about these pillars a lot, don't we? If you were with us last night, almost all the nebulae we looked at, I talked about these pillars and how they're being evaporated by hot young stars. See, there's a third one to the left of it, Daryl, maybe even a fourth.
Mm-hmm.
And the stars are, of course, in the direction opposite the pillars. So could it be these young stars are actually closer to us than the pillar, or about the same distance as the pillar, and its light is causing it to actually, the ultraviolet light and the high stellar wind rather, is possibly evaporating it around the outside, and the dense area here is shielding the rest, making it kind of fall away around it everywhere else, perhaps. That is something that happens in the interstellar medium. So,
I mean, that's what happens at the Pillars of Creation in M16, isn't it?
that is true, actually. The Messenger 16, the Pillars of Creation, the famous Hubble Pillars of Creation photo, they're being evaporated by hot young stars. In 10,000 years, it's going to look a little different. In a million years, it might be just barely recognizable. So I think it's very possible that we're seeing that everywhere we look, because that's a fundamental way in which the universe creates life and or planets and stars. It's, first of all, it whittles away at gas and dust and dense knots that are self-accreting and self-gravitationally condensing, like right here. These dense locations will remain. And then when the material behind it is shielded, the material within it can finish the condensation and form the star and or planets. Hypnotized and mesmerized. Yeah. Vera Lucia says, hypnotized again. It is beautiful, isn't it?
It is.
Even with the moon out, guys, look at what we can do. I mean, I just tell you, look at this Dark Nebula.
Yeah.
This has been something that has been elusive for a long, long time. I've never been able to see true Dark Nebula. Let me just give myself a little bit brighter shot here for a moment. I want to try something. Okay, so that comes down. Let's roll down. Okay. When it's brighter, you can see some of the noise easier, and I can see some noise in the darkness. We've stacked 18. If we stacked a number more, we would actually be able to get rid of much of this noise. You know.
It's a lot going on there at the upper left part.
Yeah, up here. You're talking about up here.
Uh-huh.
Yep.
I see a face in that brightest red part of the
Here?
upper left quadrant. Two eyes close together. Star under
Right
it, the
here?
nose, and lips right under it. A little bit to the left.
Okay.
Right there. A little bit to the right. Right there. That's his chin. You're right on his chin.
Okay.
Then you see the two dark spots above?
There are
That's
the
his eyes.
Yeah, I see it. That's cute.
Cheekbones, and the nose, and the mouth, and the whole thing.
Yeah, that's cute. That's beautiful.
Could you zoom in on it, that area a little bit?
I sure could. Let me first recover some of that black point and bring us back just a little darker at that location. Okay.
Looks like the devil now.
Uh-oh.
I see dark horns toward the top of the head.
Right here?
Yeah.
Well, let's zoom in and see. Actually, let's just zoom in. Okay, we have some noise here, but that's all right.
The depth of that's just amazing.
I know, huh? I'm gonna take us back down in our black point just a tad. Okay. Yeah, there's just, look at these pillars here. These pillars on the right side. There's a pillar here. There's more over here. Yesterday we talked about Bach globules, and undoubtedly there's going to be Bach globules in here. This is a stellar nursery. We can see pillars here. Actually, you'll see a lot of these radial pillars within these, because there are areas that are being bombarded with this stellar radiation. Hey, Katie Q, nice to see you here. Thank you for coming out. So yeah.
Another Colorado girl.
Huh? She is?
She's another Colorado girl.
Wow.
Up around Monument, if I remember right.
Wow. Well, I'll be in Centennial Friday. That's tomorrow, Katie. I'll be there. And then I'll be at the Mufon meeting where I'm going to speak. And then I will be there Saturday. And then Sunday I go back to Connecticut. I do a TV show there and then figure out when I'm coming back here. So a few things here and there. Okay, look at that. It's almost like looking at weather, on Jupiter. It's like we're digging into Jupiter's atmosphere almost. Till we back out. And you see just where we're looking. Look at that. Wow, look at that. That's just, the longer we wait, see, the better it gets.
Yeah.
Look at this. Look at this gigantic, beautiful, convoluted, wow. Can you imagine if there's a whole spacefaring civilization, or tens of them, that use these nebulae for some type of energy generation. The hot young stars are the sources, and holy cow, look at this. Well, every KDQ says, incredible good time of year. And it's like, well, yeah, every part of the year has something fascinating to see. Even galaxy season, when Leo is high overhead and Virgo, even then it looks really cool out there. There's so many things to see. When the Milky Way's not visible, well, the other galaxies are. So that's also a cool thing. What's the big star with the halo at the bottom? You talking about this guy, or down here, or one that is further down? I don't know what the star itself is called, but we could probably figure that out. Hey, Papa Tom's here. Hey, Papa Tom. PG, I'm glad you had a good day. Sort of a good day. Yeah, it does, Isabella. It makes more sense than a Dyson sphere. The Dyson sphere is the theoretical construct by which you can actually encase your entire solar system and with the star in a gigantic artificial creation. And that would be for the purpose. Wow, look at that. It's beautiful now. Look at all this stuff. It's actually for the purpose of acquiring all the energy that your solar system, your star system has to offer. That's how you would do it theoretically.
You ever read the book Ring World by Larry Niven?
Absolutely, it's a staple.
Oh yeah, that was sort of a segment of a Dyson sphere. The idea behind it.
Yeah, just a sliver.
Yeah.
And you know what? The thing is, physically, from a physics point of view, you couldn't have a Dyson sphere because the forces imparted on it by the star would be so great that you would not be able to counter them, and such a construct wouldn't hold together. It would be ripped to pieces.
Yeah, that was a great novel.
Yeah.
Larry Niven did a lot of neat work.
Yeah.
He's still alive, I think.
If he is, he's not writing.
He does with others sometimes, I think. He probably has slowed down. His one big writing partner, Jerry Purnell, he did pass away a couple of years ago, I think.
Okay.
A year or two ago.
We're going to go to 100% now because I want to explore this pillar. Look at that.
The skinny one next really stands out next to it, too.
Yeah, and then we've got one right here, and another one right here, another one right here. See that? We've got one. Can't see if there's one there. 2, 3, 4, 5. Big one, 6. Wow, that's neat. Notice also, you see these stars here that look kind of subdued in their brightness? In all likelihood, we're looking at stars that are within the nebula, and their light is being reddened by the nebula, in the same way that the atmosphere reddens the sun when it's on the horizon. So starlight is reddened as well. We call that extinction and interstellar reddening primarily. And interstellar reddening is something that, like when I was doing my astronomy work, we had to calculate interstellar reddening for a particular star based on what we knew to be between us and the star. And then we had to calculate extinction, which was the reduction in star brightness because of the Earth's atmosphere. And so before you could actually use that data that you're getting from these stars, you first had to get rid of the extinction coefficient. You had to get rid of the interstellar reddening coefficient. And then what was left was the pure data that you were trying to get at and use. It wasn't enough to say, well, I'll just do the observations every day at the same time, because that didn't work, because as the Earth is going around the sun, the time when those stars would be in the same exact place would vary by a few minutes a day. So you couldn't do that. So
There are a lot of reddish stars in that field.
yeah, I think those are the ones that are actually within the nebula that are showing through. And I think that's the reddened, interstellar reddening directly and in play. Otherwise, they would be as bright as these stars. We ask why they look so dim. It's because they're behind a lot of dust and gas.
Yeah.
And the gas won't necessarily keep them from being seen, but a light emitting nebula will actually interfere with their light. Hey JCO, how's it going? We'll just call you Jesco77. Great to see you. And happy Veterans Day to everybody else. Yes, indeed. Yep. There's tons of veterans in my family. Alright, let's zoom out and see how it looks now all zoomed out. Kind of like, how's it look all grown up? Well, here we go. Ta-da! Look at that. Is that not beautiful? That is just beautiful. Even with the full moon, even with the first quarter moon, we can make it a little bit brighter right now. There we go. Let's see if a color correction does anything good for us. Oh yeah. Color correction brings out some more of the reds of this hydrogen alpha. That is the singly ionized hydrogen. Alright, Jimmy, okay, Jimmy SCO 77. Nice to make your acquaintance. This is beautiful. This is NGC 7822. I'm not able to show you the names of these objects here because I'm in the field. I'm actually in the eye detective studio. If you look behind me, you can see there's safes back there, and if I can, you might be able to just barely see those. And so it's not like I have access. See, there they are. Okay, there's two of them there. I don't have access to the same kind of technology that I have in my broadcast studio back at FX Models home plate there. But I'll have that soon, and the same views will be awaiting us right then and there. It is just, it's miraculous. It's such a transformation in these objects. But okay, so I think we've stacked enough here, Daryl.
Okay.
I think 48 is enough, don't you think?
Sure.
Yeah. So for those that want to do their own work, which might include Isabella and others, I'm going to save this. It'll go up on the server. You'll see it right here. FITS file, that's the astronomical format. And then I'm going to save it exactly as you see it. So if you just want the pretty picture, it will be up on the server in just about 5 minutes or less. And that server location is on our Facebook page for mine, Mark D'Antonio. It's a pinned post on the page, on the top of that Facebook page. It's also a pinned post on the top of SkyTour LiveStream's Facebook page. So there's plenty to see there. And so that's done. So now what we'll do is clear this and say goodbye to NGC 7822, and then go set up for going to the next object, which will be we'll just do a 1 second shot here, and this gives us our hypered finder view. Okay. Did you have something else that you were talking about earlier?
Well, there's a list of them, a number of them.
Let's get closer.
Barnard 150, it's the Seahorse Nebula.
Oh yeah, let's do that.
Seahorse, dark seahorse.
Yeah. Okay, let's find that again. It'll be interesting to see how that works.
Stellarium has Barnard objects, does it not?
I do believe so. Yep. I believe that's B150 on this.
Yeah.
Well, let's just to the other side of Cepheus. And it's at 54 degrees up in the sky, so it'll certainly be visible to us. So let's go.
I remember that reddish cloud
Yeah?
we could see in Stellarium. It was up above this. Maybe we could look at that after. I don't remember what it is.
Yeah, I mean, it's fun to look at things that we don't really know what they really are, you know. And that's what this is all about. Finding things we don't understand.
I want to say we looked at it before. I don't remember what it is, though.
Okay, I'm sure we'll find it. If you look at the telescope, you can see that it's aiming over the north side of the building, and this is our finder star that we're going to star hop from automatically. The telescope uses a really neat algorithm for locating where it's got to go. It finds the star it knows, and it centers it automatically, and then it goes to the coordinates of the object in question. And if you look, we're at a dark nebula right now. How can you tell? Because if you look at the screen, you can tell that there's some stars missing. Why are they missing? Because something's blocking it. So we'll just take a shot here, a straight 25-second shot, and see what we're looking at. And then we will correct, move, and compose the shot, and then go stack for a while and see what we got. The Seahorse Nebula is one that our wonderful super fan Isabella Melamed actually did some wonderful processing on. So that's kind of cool that she did that. Let's see how far off we are. I don't see it. There it is. Okay, we're on it. All right. So we are going to go and live stack this, and we will see it. The best thing to do, however, is to remove this extra. There's the Seahorse right there. Dark Nebula. You know what's interesting is when you take photos of the night sky, you tend to want to avoid taking photos of dark nebula in a moonlit sky. Well, not us. Either we're stupid or we know a way around it. I tend to think it's the latter.
Say determined.
Yeah, determined is another good word, yeah.
Stubborn.
Mm-hmm.
You can see it starting to come out better already as it starts stacking.
That's right. It does right there. You can see it.
Isabella did a nice image of this.
She did. I think she did an artistic rendering of it as well. Let's see if we can get the colors more appropriate. No. Okay. I'll be right back. I'm gonna go grab something to drink. Daryl, I'll be right back.
Okay.
Hold on, folks. I shall return.
Yeah, it looks pretty settled tonight. I don't know if the moon is being an issue or not. The moon is getting bright now. Maybe one of those dark of the moon objects to really see it at its best. As Mark said, though, we have done a lot of imaging when the moon is up, and he's been able to work around it well with uh, manipulating the histogram there. The color curves and all in that graph down below the image. And again, we're looking up toward the constellation Cepheus. Cepheus the king, Cassiopeia the queen's husband. He was king of Ethiopia. Andromeda was their daughter. Uh, we're looking not directly at the Milky Way in that part of the sky. I think we're more at the edge of it, but there's tons of stars and tons of dark nebulae to see in Cepheus. We stumbled on a lot of stuff just by accident trolling around. It's called a dark nebula, Tom, because it's a cloud of dark dust. Do you see the kind of sinuous seahorse shape across the screen? That's dark dust that's blocking the stars behind it.
Ah, you're going through the concept of the Dark Nebula?
Yeah.
Yep. That's right. That's what's interesting about them is that they are black dust. And interstellar dust does not look like the dust in your house. It was created in a zero gravity environment, so it has a different look and different consistency, different density, and different materials overall. It's carbon based materials and other compounds. You can get all kinds of molecules out there. Nothing really elaborate. You don't get, for instance, you don't have just like proteins zipping around in outer space, but you have the building blocks of these objects, of these items that are out there in much smaller form and simpler form. But it's pretty cool. Let's see this. Let's see what people have to say.
My turn. Would you excuse me for a moment, please?
Absolutely.
Be right back.
Okay. It's called a Dark Nebula because the fact that the Dark Nebula is made of this dark dust that you just you basically can't see through in dense enough amounts. So that's why the stars are hidden behind it, as you can see. So we call it Dark Nebula. Radio waves can pass through, yes, but just like with walls in your house, enough material can cause radio waves to change and cause other light waves to change. Something called the dispersion, will change. If you see a spectrum of light coming towards you, sometimes that spectrum of light is lengthened, broadened out. That can change because of what it's passing through. Generally, that happens over very long distances, like fast radio bursts, these millisecond bursts of energy coming from what we think might be magnetars, which are very, very highly magnetized, highly magnetic neutron stars, is stretched. So that by the time it gets here, the pulse, which was much shorter, is stretched out by the time it gets here. And different wavelengths can be stretched different lengths. That's something that dust might be able to do in effect. Depends on what that particular frequency is that's passing through it. And for those that are interested, I'm drinking sparkling black raspberry ice drink. 0 calories, but boy is it good. I love these. Yeah. So, as we can see, the Dark Nebula is elusive when it comes to the full, or the moon, the brightening moon. And I've never tried to image a Dark Nebula at the full moon, but I suspect it'll be just as elusive, maybe more, certainly more. And Katie Q says, "Wonder if anything out there could alter the waves." And I do think that's true, Katie. There are things that can alter the waves. We know things do. Remember, you have to remember, okay, what are radio waves? Radio waves are long frequency light. So anything that can alter light can alter radio waves. Okay? So high gravitational field can certainly alter them. Interference, if light is being restricted behind a dark nebula, then certain frequencies pass through relatively unimpeded. Other frequencies are stopped and scattered immediately. Generally, the high frequency light is not passed evenly. It gets redirected and scattered. That's what happens when starlight hits a dark nebula. That nebula is always blue, and we call them reflection nebulae, and they're always blue. But why is that? It's not because the star is blue. The star could be yellow, but the reflection nebula around it's going to be blue. And why is that? It's because of the fact that the light is composed of many frequencies. The blue frequencies are at the higher end, right? And the red frequencies, the longer wavelengths, are at the lower end of the light spectrum from a single star. When that light passes toward a dark nebula, then the dark nebula dust will pass through all frequencies but the higher blue frequencies. Those it absorbs and then immediately scatters in all directions. And then we see this bluish color nebula because it's the blue light that's getting scattered by these nebulae. All right, and that is they call them reflection nebulae, but really they're scattering nebulae. Hey, Rockstar's here. We're all rock stars now. He's here.
Hey, Rockstar.
So those are basically scattered light nebulae, but I guess reflection nebulae stuck, so that's what it was. And if a star doesn't have high frequency light, then you won't see one of these reflection nebulae. Okay, a star like Betelgeuse won't have a reflection nebula around it. All right, you'll have dust that you'll see as dust shells, but you're not going to see it as a blue reflection nebula because it doesn't have enough of that high frequency light to actually be scattered by the dust. I only like purple nebulas, the Skunk Ape says. Well, then you're out of luck, because we don't have many purple nebulas. Yeah. Remember what they say about SkyTour LiveStream. Be careful, you might learn something. Alright, I think we've stuck with this one for quite a while, Daryl. It's 26 stacked. It's probably not going to get much better than this.
Yeah, thank you for indulging me.
Not a problem. It's actually a very difficult nebula to image on good nights, and as you can see, we still captured it, but
yeah,
to say we captured it is one thing. I'm not going to save this, guys. I'm just going to clear it because this is going to be a difficult object. Alright, so let's get rid of this stack.
You want another one?
Well, yeah. Why not?
Cave Nebula.
Oh, yes. We've been there before.
Sharpless,
Yeah.
Yeah, Sharpless 155.
Yes, we love that one. And how far is the cave from where we are? It's got to be nearby.
It's still in Cepheus, yes.
Yep. Okay, so let's go check it out. Alright, so we haven't looked at the cave since fixing this telescope.
Mm-hmm.
So this might be really interesting. Uh-oh, and it's pretty high up there. So here we go. If you watch the telescope up over my head, you'll see that it's going to move. There it goes. Hey, don't hit anything. You can't. And it's going to bring it over to, looks like Zeta Cephei, I believe that's where it's going. Yep, so Zeta Cephei is the star it's going to center. Here it comes. There it is. I mean, isn't this cool, guys, the way this all works? I find this to be really cool. Isabella, it's called the Cave Nebula. And you'll see it as a fuzzy thing here in a second, probably.
We looked at or for another one called the Wolf Cave, didn't we?
Yeah, we did.
I don't remember that much of that one.
Yeah. I think the cave is like pretty much centered right here. I think I see it right there.
Yeah.
Okay, so we're there, and right now the telescope has a guide scope on it, and it takes 11 seconds for that guide scope to acquire a guide star. And in that time, that's about the time it takes me to go here and say, give me a 30-second exposure, and then pop off this hyper processing and go into the live stack. So right now we already have our guide star most likely, and I can just clear the previous view. Alright, and if you look down the bottom here along the bottom row, I believe you can see that our telescope is running at minus 10 Celsius. That is the telescope's camera sensor. It's a Peltier cooler, I believe, that keeps it nice and cool, and that allows us to get more data like that you see here. Wow.
Cool.
Yeah. And while we're here, no night would be complete without also checking out our all-sky camera. I have a 12-second predefined shot on there right now. I could do anything, but we're going to go here and get a preview of what's in the sky right now. Okay, so there's 12 seconds. We're going to maximize. And sorry about the bright light there. For those of you watching on a big screen, I'm sure I just blew you out. But we have 2 seconds and you can see the image here. Okay, well there you go. And look at that. We have a satellite or a plane at very high altitude. Interesting. Let's do one more. That's nice and clear anyway. That's good. Yes, and we got 2 seconds from that. Let's see where those dashed lines go. Okay, yeah, there it goes. So that's a plane at high altitude. That's beautiful. That's heading toward the northeast, southeast. Yeah. Northeast, that was right. And this is, looks like Cassiopeia right here. See the W of Cassiopeia? Right there. And this is Perseus with Merfac here. Double clusters right there, you can see it. Ta-da! And there's our first quater moon! Look at that. Okay. Well, let's get rid of this. And let's get rid of that. All right. And now we're back. All right. Let's bring up our... All right. And let's see if we can get our color properly done here. Let's see a little better. This is the Cave Nebula right here. And there's another Dark Nebula to its right over here that we can't see at the moment. It's just off screen, basically. Alright, and we're just going to keep doing some shots of this because it's kind of cool.
Could you compose it all into one pic?
Maybe. Maybe. I think we tried to do that last time.
Oh.
But we could. I'm trying to figure out why I've got too much red. And I can see that we're way up there in the red. And that's kind of more like where I want to go. That's where I want to be, see? A little more like that. That's more the way we want to see this. That's because it's more like what it is. Okay. Maybe I'll do that composition here shortly, Daryl. If you look here, this right here, this is an object called a Herbig-Haro object.
I remember that.
Very high energy object. Daisy and Zoe, Amethyst, hello, how are you? Sorry I didn't get notification, but how'd you find out? Probably from one of my posts somewhere. Yeah. Marianne says hi to Daisy and Zoe. I'm actually in the iDetective studio using their facility, and Marianne is one of the police officers on that show. So I have to behave myself because I could get arrested. I'm not good. Or worse, tased.
Don't tase me, bro.
Don't tase me, bro. Don't tase me, bro. Awesome. Reading about Herbig-Haro objects. Wow, okay.
There's a whitish area around those two stars close together right there.
No, that's a reflection nebula, as they say. Pretty cool.
Interesting. Maybe if you, when you get a few more images stacked, I think we looked at that Herbig-Haro object before. It'd be interesting to see maybe if you can zoom in on that.
Well, I would have said in the past, probably not, but I certainly can tonight. Dalai, I'm actually not in the SkyTour LiveStream regular location. I'm 2,400 miles away from that, out in Arizona, and I'm using a temporary facility right now because I was fixing the observatory, teaching astronomy in the desert, and I did not expect I was going to be able to stream. So I'm doing it, and I don't have all the bells and whistles like I do at the other location. So I set it up to just do a real rudimentary stream, and so far so good. You know, N2W is leaving. All right, I hope to hope we can talk to you later. I think he already left. Yeah, the HH objects, as he says, yeah, are very interesting. Yeah. Isabella, I am not in the interrogation room, although I've been threatened with being tased before. Marianne, you keep your voice out of this now. Don't be giving her any ideas. All right, so we keep going here now. But let's see if we can try that, Daryl.
Okay.
We're gonna zoom in on that Herbicaro object down there. I'm gonna go right to 100% because I know we can. And then we're gonna drop down. There it is.
There it is.
Wow, that's pretty cool. We still have some noise left here, but we'll get rid of it. That's the Herbicaro object.
I wonder if that's a bot globule on the right side of it.
That?
Yeah.
Not sure. We'd have to let many more come in. Oh, Papa Tom's leaving us too. All right. Well, hey, thank you for coming, man. I know I got to go to bed too. Oh wait, I can't. Us astronomers, I don't think we ever go to bed.
I went straight to bed last night when I left here and wound up tossing and turning all night. Couldn't get to sleep.
Really?
Not like me.
Huh. Well, I remember you having trouble on one of our streams too. You couldn't get to sleep. Was that because the views were just too outstanding?
Yeah, I was so wound up. I couldn't let go.
Yeah. I think as you were thinking about telescopes and all the things you can do with them. What you can see with your celestron that you have.
Yeah.
So this is the Cave Nebula here. Another thing that I don't do, which we need to, is something called dithering. I'm keenly aware of the need for dithering. What is dithering? Dithering is where, when you take an image, you proceed to move the telescope just a few pixels in the camera one way or the other, so the camera sees a slightly different scene. And by doing that, you make sure that you don't get strange artifacts on the images. So far, I actually haven't had any, so this is pretty good. Oh. Yep. Yes, sirree. There's another Herbicaro object in this too, is there not? Besides this one down here, isn't there another one?
I thought before you can see it there on the left. It's very faint. I thought there was another one just to the left of it. Yeah. And I know when you zoomed in on that, I remember saying that dark space between them, I thought it looked like a peanut before.
Yes.
And with the better resolution now, when you zoomed in, it didn't look quite the same.
Okay. Well, we also have a moon, so.
Yeah. Yeah, the red cloud farther to the left there.
Look at that.
Yeah. I was thinking at the time, perhaps I thought it was a dark cloud kind of breaking one object in two.
Okay.
Or it could just be two objects.
Wow. Okay, well, we've done 22 stacked here. I'll actually save this if people want to play with this. So I'll pause it, save the stack, and save the image exactly as we see it. Alright, and then we can go out of this and say goodnight to the cave. There we go. Now we can come back to our planetarium image. And
can you zoom out a little bit in Stellaria?
yeah.
Okay, there's two red clouds. There's one to the left there, and there was another one that was just to the right there.
Yeah.
I don't remember what we saw there, but I think we looked at them.
Okay.
Would you want to try them again?
Of course. Let's find out what we're looking at here.
The one on the right looks pretty busy.
It does, doesn't it?
Yeah.
I think we'll do that. All right, we're going to go here. I like going places that we don't know what we can expect to see.
That looks pretty big.
It does.
Can you overlay your field on
Yeah,
that?
I can. As a matter of fact, I'm about to do that.
Whoa.
All right, it's going to take up the whole screen. It should just go to that star. Okay. So now it's going to go to that little star. And Bonnie says, let's go see. Scotty said that in a Star Trek episode where he was a little bit drunk. And Scotty said, let's go see. And Kirk was like, Scotty, I think you've had enough. Mr. Sulu, get us out of here.
It's green.
Well, that's the episode with the Kelvins trying to get him drunk.
Yeah.
What's this? And he goes, it's, as you said, it's green. Very funny. Okay. Discover the unknown. That's what we're doing. You know, in some ways, guys, it's like we're pioneers. Pioneers of the night sky. We're going places that haven't been looked at. Here's the thing. Think of it this way. What are the chances that there's somebody else in the world looking exactly at what we're looking at right now? The chances are actually quite slim. You know? Chances are probably quite slim. So I'm pretty much thinking that we have a unique capability here. I gotta clear that. That's the old one. That's the cave. I'm gonna clear it because that's the cave. All right.
If you remember.
Ooh, wow.
Wow.
Let's check this out.
Mentioned it before, but you were one of, I think, 5 or 6 cameras on the whole planet that managed to catch that meteor impact, weren't you?
Yep, that's right. It was January 20th, 2019. There was a lunar eclipse. And during that lunar eclipse, wait, didn't we were just here.
I don't think so.
Yeah, we were. Look, there's that pillar I was talking about.
Oh.
Oh, we went to the same place.
Never mind.
Okay, well, you know what? So much for being pioneers. All right, well, here's what we'll do. Let's take ourselves over to the other one we're looking at. It was January 20th, 2019, and there was a lunar eclipse. And at the height of the lunar eclipse, we had our cameras looking at the moon's deepest red area. And at that point, in fact, right at that point, we ended up seeing a meteor strike the moon. And there was only like 5 other groups on the planet that actually saw it. And we were one of them. So that was pretty cool. That was sort of historic. Okay, we're going to go to this guy now. We're going there for real now. So we're going to get out of this stack.
Sure is neat looking.
Yeah, well, remember we watched it come together?
Yeah, we talked about the pillars down in there.
Yes, sir. Okay, so let's do this. We'll go 1 second.
Still neat looking. Bella has a question for
I
you,
see it.
Mark.
I see that. Yes, Isabella. We have members all over the world, so certainly we would investigate. If you actually have imagery or a video, then it will be me that actually investigates it as a foreign sighting. Okay, now I think we are at our location.
I see nothingness in several areas.
That nothingness seems to be a dead giveaway. That
Yeah.
somethingness is happening. Nothingness leads to somethingness. 25 seconds. And go. And get rid of that. And go to the stack. Go to the stack. Clear it. That's the old one. Green bar down the image. Down the bottom there shows the imaging status. We're 4 seconds away. What is it? We stand here with bated breath. Oh, look at that. Looks like the Cave Nebula once again.
I thought we were offset from that when we looked at the cave.
That's the cave right there.
Yeah.
Okay, so I think we want something to the left of that. And let's go do that. That was kind of funny.
I'm shooting blanks tonight.
It's alright. I see some up here. I know we haven't looked at this. How about that? This looks interesting. That's interesting. Looks like a couple of nebula right there.
Yeah.
Alright, let's go with that star. See what we get. The telescope's going, what? I just got here. Okay, so we're going to clear that. Clear that. Clear this. And go here.
Satellite.
Yep, and Zeta Cephei is being centered. And there's the satellite coming through. And Zeta Cephei is being centered up. And then after it auto centers Zeta Cephei, what you see right there, it's going to head to that little tiny star that nicely frames the nebulosity. Uh-oh, look at that. Oh, this looks like an interesting location. Strangely familiar.
It is.
Hmm.
The star cluster on the left looks familiar.
Yeah, I'm wondering, are we fooling around in the same place we've been playing all this time? This doesn't tell us anything. Well, we'll find out, won't we?
Is that the star cluster to the right?
Yes.
Down a little bit?
This guy?
Yeah.
I believe so. Yes.
Yes.
Well, actually, I don't know if we've actually seen this, Daryl. The image is reversed right now for us, so just so you know. And what I'll do is I'm going to basically move the telescope this way, my other way, and give us a little more room on that side. Framing things nicely. Okay. Okay, just a big jump here. Okay. And just a tiny jog downward the telescope so the field is raised up a little. And that's good. And now in this time we'll take to set us up for a 25-second photo. At 325 gain, I'm going to go to 350. Do it this way. There we go. And do this. And then go in there, stack here. Plenty of time to see what's coming in. Let's find out. Wow, look at that.
Wow.
That's a pretty location. And we see all those objects that we saw in there.
Yeah.
And then some. Okay. Once we get a second image, then we can reasonably start processing to get some better look at it.
That star cluster on the left sure rings a bell.
Yeah, it kind of reminds me of a few clusters. Hey there, Lord Newbert. See if we can. Yeah, see, you can see that this is a whole area full of red diffuse hydrogen that's glowing. See the soft glow in the background here? It's everywhere, all throughout this image. Let's go check it out, shall we? Let's just hang out for here for a little bit and watch it develop. Here we go. Oh, look at that. Wow. I can't, you know, sometimes you just can't take your eyes off that. Yeah, take the moment to give us a thumbs up, will you? That helps us with the YouTube algorithm. You know where we are, Daryl.
I'm sorry?
I know exactly where we are. Do you know where you are? I mean, Isabella should know where we are.
She said the Bubble Nebula, didn't she?
Yeah, she's correct. See, here's the bubble right there.
Oh, okay.
Yep.
Then that star cluster, I want to say, is M52.
Oh, well, let's go see. I don't think so. It's this. And it doesn't have a designation. Not a standard one.
Oh. Okay. I remember M52 being in a sort of a similar situation in an image.
Yeah.
Star cluster over to the side.
Mm-hmm.
Yeah, Isabella's absolutely right. That's the Bubble Nebula.
That's right.
She says there's the supernova on the right.
Is she talking about this?
I don't know.
It doesn't look like a supernova.
Isabella's going to be running this joint.
Well. Hey, Snickers. Dog came in to say hi. Let's see what we got here.
It's a pretty field.
It's a beautiful field. You got some Dark Nebula right here.
Yeah.
Let's actually increase our black point a bit. Okay, that looks good. Isabella says the supernova is not on the right, it's the other right, so on the left. I can tell you this Wolf-Rayet star is going to eventually, this star right there, actually we can now support pulling in closer. Let's go to 75%. We'll see some noise, but it'll be okay.
Yep, there's the bubble.
Yep. Yeah, that star right there is a Wolf-Rayet star. It's a very strange category of star that actually has pumped off its outer hydrogen envelope. All stars are made of hydrogen, and the outer hydrogen envelope was pushed off by this star, almost like a petulant child pushing his dinner on the floor. The dinner is sustenance, and the hydrogen is something that could potentially be fuel at some later point. But when it's in the outer envelope, a lot has to happen for it to go to the core, where it could then be utilized and made into the products that are fusion products. And we don't actually see that happening with these stars, but it's really cool to look at what happens when they when they blow up, because they're very unstable stars in a sense, and they're already at the latter part of their lives. And so these Wolf-Rayet stars are all destined to explode into a supernova. Another famous one is the one known as Thor's helmet. Another famous one is known as the Crescent Nebula that we saw yesterday. And so there are these Wolf-Rayet stars throughout the heavens, all far enough away, and so they're not going to hurt us. But if you think about it, these stars are actually quite dangerous, just not to us.
I remember this image. If you look down in the lower left part of the screen, to the lower left of the bubble,
Yeah.
the star trains, I remember remarking on before, kind of looks like waves on a pond.
Down here?
Yeah.
Okay.
You see that?
Sorta.
They're all curved, like ripples on a pond.
Yeah, kinda, sorta.
Kind of, sort of.
Kinda, sorta. I see that.
Isabella says we could see it easier when we were zoomed in on the bubble. The dim nebulosity to the right of the bubble, there's a very red object in it. She says that's Nova Cassiopeia 2021.
Oh, yeah?
Yeah, and I think Stellarium showed that too.
Okay. So that's this right here.
Yes, if I understood her correctly.
She might be right. I was unaware of a supernova in Cassiopeia.
I think I remember hearing about that. Uh, I mean, are we in Cass now, or are we still in Cepheus? Oh, no, the other side.
Yeah, that's what she was saying. Okay.
The other right side.
Yes, I guess because she's in Bulgaria.
The other right.
She must be coming at it from, the other side.
Okay, so it'd be that bright red star
Exactly
over
on
on
the
the
other
left.
side. Well,
Yeah,
that red star there.
yeah. I did see Nova Cassiopeia 2021 mentioned in Stellarium.
Okay, that looks like just a red star
Uh,
below the cluster. She says. Oh, you saw it in Stellarium? Okay, hold on. Okay, there it is, right there. Okay, it's probably that bright star.
uh, the bright whiter star
Yeah,
to the
like just
lower left.
right there.
Yes.
Yeah, I think this is the one she's talking about.
Are we in Cassiopeia now?
Well, I just got back from Stellarium. I don't know, but if there is, it says Nova Cast. That's just down here.
Yeah, and that's the bubble.
Yeah, so this must be the Nova.
Isabella's kicking butt.
I love it. That's great. Let's just go back and make sure. Um, now what we're gonna do here first is I'm gonna set up the boundaries. Let's get rid of our lines here. And now back out. And there's a constellation boundary there. Okay, so that must be the boundary of Cassiopeia into here.
Okay.
Okay. Yeah.
Yep. Yeah, there's Cap right there.
Yeah. So if you draw a line from the bubble over to Cassiopeia Nova and straight up, it's almost like a 90-degree angle.
Yeah.
So that implies that this
Oh,
is not it.
right.
It says it's in here somewhere.
That's the salt and pepper cluster.
Yes. So if you do this, go down, it's almost like this is it right here. I don't think that's it. It might be this. It's gonna be one of those dots. Right? So that's it right there. It's gonna be one of these. Probably this guy right here. That looks like right about the looks where it belongs. But you know what? It's possible that it's already down to a much lower magnitude anyway. Fainter, in other words. Higher magnitude. Well, let's go see.
Pepper Cluster. The Bubble, Northern Lagoon, Nova Cassiopeia. Yeah, she has the red star circled,
I see that.
and that other object is the Northern Lagoon.
So saying that this is the Nova Cass right here?
I think so.
Hmm. Well, if it's a nova, then that means it's a red supergiant with a white dwarf companion. Because it's not a supernova if it's a nova.
Right.
And what happens is the white dwarf, um, the red giant, fills what's called its Roche lobe. What's that mean? It means that as the red giant swells in size, and it has this white dwarf orbiting it, okay, the red giant's material can actually leak off, go through the center of rotation, and leach onto the white dwarf. And white dwarfs can only have a certain amount of mass before something happens on their surface. That something can be that the entire mass of hydrogen that now sits on their surface can go into runaway fusion all at once and just cause the star to just erupt very brightly, and that could cause it. The other thing, in some cases, it could also destroy the white dwarf star. So there's a possibility that both can happen. Yeah. So very good, Isabella. That was very good. Okay, we did 37 of these. I think we're bubbled out. Yeah. Pause it.
Cool picture.
38. Yeah. Okay, so now.
You know, that's another of those images that I just see dark lanes all over the place on that. Up toward the star cluster, and
Yep. Right there.
yep, the curved one hanging down to the right, and
Right.
one going across, and one going up to the left, and another big one over in the top left corner.
Well, because we have lots of them doing that.
Yeah.
We got this.
Same sort of thing
here.
as where I see the waves down in the lower left-hand corner,
Okay.
or when I see the spider legs on whatever that other object was we look at.
Oh yeah. Donald,
So
I
then,
don't
in the
have
whole
it.
image, I'm sorry.
I was gonna say, Donald, I don't have any music tonight because I'm not at our site. If you notice the video, it's very different. I'm in Arizona at another location, so I don't have the music tonight. But I will be back Sunday night, and when I stream next week, we will be back to our normal setup. Go ahead, Daryl.
She says the object at the upper right is the bright red object. No, farther
Oh,
down.
this?
That's the Northern Lagoon.
Yeah, yeah.
Could you zoom on that?
Yes, I can. I want to know what this object is down here.
Uh-huh. Pretty nebula all by itself.
I know.
No singing tonight, Isabella. Sorry.
Unless she can.
It's pretty.
Yeah. What I like about it is the fact that we can do it. We can show it.
Uh-huh.
We were very limited before. I can't believe how much more flexibility we have.
Yes.
Nice. Oh, yes, you're right, Donald. There are no more sound effects from Skype as I was trying to bring Daryl in. That's correct.
They were hearing that?
And of course they were. That was coming out over my channel, which was very obvious.
Oh.
That's all right. Okay, in the year 35 or 25, 25. I remember that song.
Oh, yeah.
Look at the subtle colors in here. We have Dark Nebula that trails up here. It's amazing how much comes out, you know, under the scrutiny. It's just amazing. Nice and subtle.
That is a very red object in that cloud.
Yeah, right here. Oh, sorry, I'm yawning already. I'm actually exceedingly tired. So I'm not sure I have a lot left. Okay, so this is gonna go.
It's not even 2 a.m. yet. Are you all right?
I'm very tired. I haven't had a lot of sleep.
Yeah.
Let me.
Well, whenever you need to call it, call it.
Oh, I am going to.
You want to... How high is Perseus now?
I want to do this one more object that you were talking about before in Perseus.
Oh, okay. What, 1333?
Yeah, we can try that now, I think. Alright. So let's go see. The
Phantom Tiara.
It's right near the Pleiades.
Yeah.
I'm wondering whether that'll work right now. It says 50 degrees. Well, we can try it. What have we got to lose? Nothing. Okay, let's get this down just so I can watch the telescope do its thing. Okay. Uh-oh. Okay, telescope is acquiring. That's good. Okay. Well, there it is. It worked. It's right there, and it's clear of the building. See?
Yes.
It's going, properly. Okay, cool. All right. Let's check out the Phantom Tiara, whatever that is. We'll give it a 30-second trial run, shall we? And let's go here. Go into the stack and clear what's in the stack. I did save that, didn't I? I don't know if I saved that. Uh-oh. That's okay.
Says it's a stellar nursery in Perseus.
All right.
Yeah, it looks like it's right on, nearly on the Taurus border.
Mhm. Oh, that's interesting looking already.
That was interesting seeing the Perseus cluster last night.
The Maffei, is it Maffei 5 or Maffei 1?
Caldwell 5, it was a MAPE group.
Yeah.
Was it Caldwell 5?
Caldwell 5 was that face on Galaxy.
Oh, okay.
Maffei,
Yeah, you're
Maffei
right,
was
you're right.
the group of galaxies. Yeah. Okay. Yeah, look at that. With each exposure and each stacked image, the noise gets less and less pronounced and looks better. Um, let's go see here. Let's go to 50%.
Wow.
You can see the noise in the image, of course. That's going to change. And if we just kind of go up and grab that and move it, it'll change the black level.
Looks cool.
It does. Looks like it has a reflection nebula component too.
Yeah. Very red area in it also.
Yeah. Wow.
I think that one's one that could use some focal length on it.
I agree.
There's a lot actually going on inside that.
Yeah, there is. All right, folks. Well, I am going to end up calling it. I'm kind of tired. I'm not able to stay up any longer.
Poor Mark.
Eh,
It's
no.
not even 10 o'clock yet.
That's right. Now watch. I'll go try to go to bed and I'll be wide awake. All right. Well, we have done 7 of these. We'll go to 10, and then I'll save it so we have the object. But guys, thank you for coming out. It was a lot of fun having you here as always. And we will be back on maybe not the next clear night, but we have a few things that we have to do. And one of them will be that we have to I've got to take care of a bunch of things back when I get back. I've got to build a couple of submarine models. I have to do that show, and then we'll be ready. We'll all be all good. So that's no problem. All right. So this is 9, and we're about to go to the 10th. There's 10 images. That's a cool little nursery. And before we lose it, let's go to 100% on this and see what we got. It'll be right in the middle. Okay, 75%. That's really interesting.
It is.
Wow. Okay, well, we're going to save it. And then we're going to save exactly a scene. Alright, and then we're done. So we'll bring this down to 1 second again.
That's really cool looking.
It is. And then we'll come here. Dump the stack. So we dump the stack. Okay. Alright. Get rid of this. Get rid of this. I'm shutting things down in reverse order. The last thing to go will be the telescope control program over on the left. See? Somebody else is yawning. Daryl.
Yeah, sorry.
No, it's alright. Okay, and the focus was good, so we didn't have to play with that tonight. But what we can do is look to see what the temperature was in there. The temperature in there is, say 65, 67, 67.6. Okay, disconnect.
Let's get down in the 20s here tonight.
That's cold. Yeah, we can get rid of our all sky camera. We don't need this. Alright. And now what's left is to park the telescope and then disconnect. So there goes the telescope heading toward the parking position. Alright, and once it gets into the parking position, you'll see that the stars start to drift across the screen. That's because we're now just sitting still, the telescope's not tracking, and we're just rotating out from under the stars with the telescope. And then we can just disconnect the camera. And then kill this system. And then watch our roof close. There we go.
I hear a clock ticking. Is there a clock in there with you?
That's actually a time bomb. But
Oh. Okay.
yes, there's a clock.
Yeah.
Alright, and there goes the roof.
Sounds like a big one. Tick.
Laura Lubert asked, how did the Mufon training go? It went very well. I taught astronomy out in the desert and did a sky watch for everybody and showed them what's going on, the kinds of common things they could see. It went very well. It was very nice. So thank you for asking, Laura. And then I am going to be in Colorado this weekend. They're sending me from Arizona here to Colorado, where I'm actually going to be doing a talk out there as well. So that'll be kind of nice. Then I go back to Connecticut, where I go to sleep.
Good for you. Get some rest. Have a safe trip, too.
I will. And
weather's been middling here lately. Been sunny down on the Front Range, but it's been very windy lately, so
okay.
Who knows what you'll be coming into tomorrow.
Yeah. We'll see. Okay, and then this is that. and this is that. And then I can shut down this process. And away we go. Alright guys, I want to thank you for the attention and your kindness. It was so good to see you guys here. I look forward to having you in the next SkyTour LiveStream. The next stream you'll probably see will be from our regular location and not here in the iDetective studio. So that said, I hope you guys have a good evening, and I will talk to you again. Say goodnight, Daryl.
Good night, Daryl.
All right, exactly. All right,
Night,
folks.
everybody.
You guys have a good night. We'll talk to you later.